Hello everyone, hope you're doing well. On this part, we have the binomial probability distribution. Here we have steps. We should have all these factors to have binomial probability distribution. The first one is the procedure should have fixed number of trials. Then second step, these trials should be independent. Then number 3, here we should have success and failure. But that means we should have all outcomes. Then number 4, the probability of success should remain the same in all trials. Okay, now what we have here on this part is for success we will use S, and for failure we have F. Here P is probability of success, so Q is probability of failure. So this part is exactly the same as having Q this. P is success. So 1 minus success, this part is failure. So this is probability of failure, and this one is probability of success. Okay, and to show the number of trials we use N, and number of success in N trials we use X. So once again, P is for the probability of success, and probability of failure is Q, and this X, so that is probability of X, and X was here on top, number of successes in trials. Okay, now let's work an example. On this part, we need to find out which one is binomial experiment. So do we have binomial on each part? Part A. An experiment in which a basketball player who historically makes 80%. So this is our probability. Okay. So I'm going to have that, I consider that as success. So this is, so 80% of his free throw is asked to shoot 3 free throws, and the number of free made is recorded. So what we have on this part is just that one. We have 80% probability of success, and what that means to find probability of failure, Q is equal to 1 minus P. So Q is equal to 1 minus 80%. Here is 20%. So this part is failure. So now we should follow these steps to see if do we have binomial experiment or not. The first one, the procedure should have fixed number of trials. Okay, so he had 3 free throws, and that is N. So the first step, we have fixed number of trials. So N is 3. Then on top here, second step, you should have independent. So I want to see if do we have independent. See, he's trying the first and then second and the third one. So all these are independent of each other. So we have step 2, independent. Then third step, do we have 2 outcomes on this part? So we have our outcomes. And what that is, he misses his shot, shoot or not, so makes or misses. Then step 4. Okay, here is the probability of success remains the same in all trials. Probability of success was based on what was given was 80%, and here for failure we got 20%. So probability of success is P equal to 80%. And based on that, we can say, okay, probability of failure is 20%. So we passed all these. But that means this is binomial. Okay, now part B. Number of people with blood type O negative. So here we have type O negative. Based on a simple random sample of size 10. This is number of trials is recorded according to the American Red Cross 7%. The 7% is probability of success. Okay, so 7% of people in the United States have blood type O negative. Okay, so again, starting from the first step, do we have fixed number of trials? Yes, because here we have, this is a random sample of size 10. So fixed number of trials. N is 3, or N is 10. Okay, then step 2, here again on this part, we have independent. Then what are our outcomes? We have 2 outcomes. And what that is, having this blood type O negative or not having that blood type. So O negative or not O negative. Then number 4, probability of success is so this is given on top is 7%. So we pass that part in. Based on that, we can find a probability of failure, and that is Q is 1 minus P So 1 minus 7%, and that is 93%. So we passed all these steps, but that means this is binomial. Now part C. Probability experiment in which 3 cards are drawn from a deck without replacement. What's important on this part is that we have this one without replacement. Since we have without replacement, what that means here is dependent. We had this part before, remember? Or when we had 52 cards, that part. And the number of aces is recorded. Okay, so starting from the first step, we should have fixed number of trials. So fixed trials. Okay, here we have 3 cards. So this n is 3. And as I said, since this one is without replacement, we don't have independence, so this part is dependent. So do we have independent? No. So because of that, without replacement. So without replacement changes the probability of success. So what that means, this is not binomial. Okay, now in this part, we want to compute a probability of a binomial experiment. Okay, now on this part, we want to compute the probabilities. Okay, so on this part, we want to compute the probabilities of binomial experiment. First method is without using calculator. We have this formula for this part. Here n is exactly the same as the previous page. Number of trials, x is number of success, and p is probability of success, and q is probability of failure. So this one is probability of number of success that we have among n trials, and here is n factorial. So that is factorial. And what factorial is example for that part. So for example, I'm starting with easy one. We have 3 factorial. That is equal to, starting with the number is here, we have 3 starting with that number. So 3 times 2 times 1. The answer is 6. Another one, 5 factorial is equal to, starting with 5. And 5 times 4 times 3 times 2 times 1. That is equal to 120. Okay, now on this part we have at least, what that means is no less than or greater than or equal to, and this is the maximum for it. For example, if in case we had probability of x greater than equal to 6. For that part, we need to consider the numbers that we should have for x are starting from 6, then 7, 8 to infinite. And here we have greater than or more than. So probability of x greater than 6. So for this part, I don't have this equal to, so I'm not going to have that 6 starting with 7. So 7, 8, 9. Okay, same thing for less than and less than less than equal to, and here equal to. Now let's work on an example. Okay, on this part, according to flight states, American Airlines flights from Dallas to Chicago are on time, and that is so. This on time is probability of success. So it's 80%. And suppose we have 15 flights. That is, number of trials is n, or randomly selected, and the number of on-time flights is recorded. Part A, explain why this is a binomial experiment. Okay, so again, first step, we have fixed number of trials, and that is equal to 15. Here we have 15 flights. And these flights are independent of each other, so we have independent. So the answer for that part is yes. Then step 3, writing all the outcomes. Our outcomes are, we have to if we have on-time flights or not. So on time. Or not on time. Then step 4, probability of success is given as 80%. So P is 80%. And based on that, probability of failure is, okay, Q is 1 minus P. So 1 minus 80%, that is equal to 20%. So this is failure. Okay, so we pass all these 4 factors. What that means, this was given. This based on what we have here, we already know that this is binomial. So I don't need to write yes binomial because it's not asking us, but I'm writing it. So this was the reason why we have binomial. Okay, part B, find and interpret the probability that exactly 10 flights are on time. I only want to find this part, so I'm not interpreting that. So finding the probability that exactly 10 flights are on time. This 10 is our x. So 10 flights out of 15 flights are on time. That's why this is x. Okay, so probability of x, I'm using the formula for that part is n factorial divided by n minus x factorial times x factorial multiplied by probability of success to the power x times probability of failure. The power is n minus x because we already have this x here on top. So I should find what the remaining is. Okay, so that is equal to n as 15. So on top it is 15 factorial divided by n 15 minus x is 10 factorial times x factorial. Now p is 80% to the power x is 10 multiplied by q is, or probability of failure is 20% to the power 15 minus 10. Okay, now finding the answer for this part. Here on this part, okay, let me write that. So we have 15 factorial divided by, here we have 5 factorial times 10 factorial. Okay, so the answer for this part is 3003. Then multiplied by so the answer, the final answer is 0.1032. Okay, so method number 2 using TI-83 or 84 plus. So first step, you need to press second, then bars. Then if you had, let's see, so on this part we have this number of trials is 15, probability or probability of success is 30% or 0.3. And here x is 8. So x is equal to 8. When you have this equal to, you need to use probability binomial PDF. So again, you're using binomial PDF when you have x equal to. I don't have less than equal to, I have equal to. But in this part, we have x less than equal to 8. That's why we use binomial CDF. Okay, now a working example. After this method 3, so method 3 is using table. So let me show you a table. I posted this on Canvas. So we have this table here on top. See, we have binomial distribution. Here is n, here we have x, and these on top are probability of success. Okay, back to this part example. I'll show you how to use that table. Okay, example number 3. According to flight states, American Airlines flight, so we have exactly the same thing, and these are on time. So that is 80%. So this is again probability of success. And again, we have 15 flights. That is n. So part A, find and interpret the probability that exactly 10 flights. That's 10 is x. are on time. And that's why we need to use calculator. Say we have exactly same thing on top. This one also was 10 flights. Now in this part, it's asking to use calculator. Okay, I don't have my software installed on my PC, so instead I'm using another program to take picture of my calculator. So I'll show you that. So first press second, then words. Okay. Okay, then I'll take picture of my calculator. Here is what we need to find as binomial PDF. So you press second, then words. You need to scroll down to find binomial PDF. After that, press enter. Now you should see this picture. So this page, we have number of trials, probability of success, and X. So enter all these. So for number of trials, we have 15. Probability is 80%, and X is 10 flights. Okay, I have this. Then press enter, enter, and again enter. Okay, here is the answer is 0.10, rounding is 32. We got exactly same answer at the previous part that we didn't use calculator. So rounding is 0.10, 32. Okay, so part A. Here, probability of X, and that is equal to 10. Using calculator, we have binomial PDF. Then we enter data first, N was 15. Then P is 0.8 or 80%. Then X is 10. So this is N, here is P, and this one is X. And we rounded it, the answer is 0.1032. Okay, now interpreting this part. In a random sample, the probability of exactly 10 flights being on time is 0.1032. Okay, now part B. Find and interpret the probability that fewer than 10 flights are on time. On this part, we want to use table. Okay, probability that that's X is, here we have fewer than 10. So we have X less than 10. I don't have equal to. So that is equal to the numbers that are less than 10. We can have 0 flights. one fly. Okay, 6 flights, 7, 8, and 9. Okay, so we have all these. Okay, now use table. Okay, so on the sport n is 15. So finding 15 on the first column. Okay, so here is 15. Then our probability is 80%. See, here we have probability on top. It's up to 50%. And here, the bottom, we have more than 50%. Here is 80%. And when you use these probabilities on top, x starting from this point is 0, 1, 2, 3, up to 15, because this n is 15, that is up to 15. But when you use probability here in this part, that will change the way you're starting your x's. Here you're starting from this part. This 15 is actually 0, so that is 0. Then this 14 is 1, 2, 3, 4, 5, up to this one will be 15. So in this case, since we have 15 on that part, now we want to find, okay, what was that? AD was here, moving up. So this is the column that we're working on. Here is what we need. Now, you can see that we have nothing on this part. When you have nothing, that means that here is 0. So for x equal to 0, we have 0. For x equal to 1, we have 0. For x equal to 2, we have 0. And for 3, again, 0. And also for 4, we have 0. And this one is for n equal to 5. So that is 5, because here is 0, 1, 2, 3, 4, 5. 10 is actually 5 in this case, and that is equal to 0.0001. The probability is that number. Okay, then after that, so this is 5, 6, okay, 5, 6, 7, 8, 9. So we need these numbers. Adding all these is the answer. Okay, so probability of 0, we got 0. Probability of 1 is 0. Probability 2 is 0. 3 is 0. And 4 was 0. Now probability of 5 was 0.0001. Here was 0.0007. Here is 0.035. And probability of 8 is 0.0138. And for 9, we have 0.0430. Okay, so adding all these, the answer is 0.0611. Okay, so this was using a table, or we can use calculator. I didn't ask to use calculator, but let's work on that part too. So using calculator, here we have less than, I don't have equal to. Based on what we had here on top, see, Here I have less than, so I need to use binomial CDF instead of PDF. So use binomial CDF. Again, exactly same as PDF, starting with NPX. So N is 15. Probability is 80%. And X, here we have less than 10. So this X is not 10. Here is 9. Okay, let me show you the steps. So first, again, press second, vars, scroll down to find binomial CDF. Okay, here is what we have. So first I press second, then vars, then scroll down to find binomial CDF, then enter. Now you have this page. Enter the numbers for trials. We have 15. Probability is 80% and X is 9. Okay, I have this. Then press enter. So this is 9. So press enter, again enter. Here is my answer is 0.06105. Rounding that, we have 0.0611. So exactly same answer. Sometimes you may see that you don't have exactly same answer. That's fine because calculator is better to find the answer. And the tables may not be updated. So the answer, we rounded that, is 0.0611. Okay, so I only interpret for the first part. I'm not interpreting for these. I'm only want to show you how to find the answer for each part. So find the probability that at least, here we have at least 10 flights are on time. Here on the spot again, use table. So probability of X when X is greater than or equal to 10, because we have at least 10. So starting with the numbers that are, so that is equal to 10, and then greater than 10. So probability of 10 plus probability of 11, 12, up to 15, because we have 15 flights for number of trials. Or we can use, using that one, using table, or we can use this one. So probability of X greater than or equal to 10, that is equal to 1 minus probability of X less than 10. So 1 minus, from the previous part we got this number, so this is probability of X less than 10. We can use that one to find the answer for part C. So it's 0.0611, and the answer is 0.9389. So either one works. So for this one, again, exactly same as the previous one, using table, we need to find probability of 10, 11, 12, 13, 14, 15. So the numbers that we added here, so see here is, I said that since we're using 80%, this is this is not 0, this is 15. So starting with that one, I have probability of 15. So probability of 15 is this number, then 14, 13, 12, 11. So this is 11. And here we have 10. So adding all these numbers, the answer should be 0.9389. Let me write those here on this board. So that is equal to, for 10 we have 0.1032, for 11, 0.1876, for 12 we have 0.2501, and 13.2309, and 14.1319, and for 15 we have 0.0352. So adding all these is equal to 0.9389. Part B, find and interpret that the probability is between 8 and 10 flights. So it is between 8 and 10. So that is equal to, so this is equal to, starting from here, we have probability of 8, 9, 10. Okay, here we have all the data from table. Probability of 8 was equal to 0.0138. Probability of 9, 0.0430, and probability of 10 from this part is 0.1032. And that is equal to 0.1600. Okay, next page. Okay, now let's probably want to find a mean and standard deviation of a binomial random variable. So here is mean, and here we have n number of trials, p is probability of success. On this part, standard deviation is the square root of n times probability of success times 1 minus p. This 1 minus p is q, or probability of failure. And this p was probability of success. Okay, hope you remember the empirical rule, which was based on Bell-shaped distribution. Okay, on this part, we're going to use the within 2 standard deviation for. So within 2 standard deviation, what that is, mu plus mean plus 2 times standard deviation is our maximum usual value, and mean minus 2 times standard deviation is our minimum usual value. And this was 95% of observations were between were in this interval, so within 2 standard deviation. Now example. So according to American Lung Association, 90% of adult smokers started smoking before turning 21 years old. So part A, computing mean and standard deviation of the random variable x, the number of smokers who started before turning 21 years old, in 200 trials of the probability experiment. So here on this part, we gonna work based on what we have here on top, usual values. And what that means, I need to find mean and standard deviation. So on this part, it's asking us to find mean and standard deviation. And on the second part here, it's asking would it be unusual. Since it's asking if that is unusual or not, I'm using what we have here on top. Okay. So the number of trials we have is here 200. Then probability of success is on top here, is 90%. So based on that, probability of failure is 1 minus p. So 1 minus 90% is 10%. Now finding a mean is equal to n times probability of success. So n is 200 times p is 90%. So the answer for this part is 180 smokers. And standard deviation is the square root of n times p times q. So here we had n times p times 1 minus p, or that is equal to n times p times q, because 1 minus p was q. Okay, so this is equal to n is 200 P is 90% and Q is 10%. Okay, so that is equal to square root of 18. Use calculator. Running it is 4.2. Okay, then part B. Interpret the mean. So for mean, we got 180 smokers. What that means, in a random sample of 200, we expect that 180 to have started smoking before turning 21. Okay, now part C. Would it be unusual to observe 185 smokers who started smoking before turning 21 years old in a random sample of 200 adult smokers? Why? Here on the part we have 185 smokers. So what we have for usual values, so for max we have mean plus 2 times standard deviation, and that is equal to, for mean we have 180 plus 2 times standard deviation from previous part was 4.2, and that is equal to 188.4. Okay, now finding minimum value. So this is a mean minus 2 times standard deviation. That is 180 minus 2 times 4.2. It's 171.6. Okay, now we're gonna see if is that usual or not. So the usual range is from the minimum value is 171.6 up to that's max value is 188.4. So based on that, since 185 smokers is in the range, it is not unusual. Or in other words, that is usual based on this part. So we have usual values. So range, it would not be Okay, so the answer for this part was not unusual. Okay, we finished this part. And later we'll start the next section from another chapter. Okay, take care. Bye-bye.